Hi, I just picked up a LogiMetrics 300 traveling wave tube amplifier on eBay. If you have been following my channel, and by the way, I strongly recommend that you do so by subscribing to this channel. This is the best way to express your support for the content creation on this channel. Anyway, so if you have been following my channel, you probably had seen me doing an extreme teardown of a Hewlett-Packard 493A traveling wave tube amplifier, which by the way is a C-band 4 to 8 GHz amplifier and has an amplification factor of about 30 decibels. And has a maximum output power of roughly 1 watt or so. If you haven't seen that video, I strongly recommend that you take a look, as I also covered how a traveling wave tube works in that video. And I will also include a link down below for those who are interested. Anyway, back to this LogiMetrics 300 traveling wave tube amplifier. It was sold as not working, and by just casually examining the exterior, it looks like it does have some issues. For example, the reset button here on the front panel doesn't really appear to be working at all. And it was also missing the fuse and the fuse cover, which probably is one of the least of the problems anyway. If I have to guess, this unit was likely made in the early to late 70s, and probably was decommissioned decades ago. I could not find any service manual on this unit at all. The only information I could find is on the A300 series, but the schematics are likely to be very different, and I'm not sure how much that is going to be useful for the A300. Since LogiMetrics has long gone, it was acquired by L3 Communications back in year 2000, the chances of getting any supporting information on this half a century old equipment is pretty slim. Now, of course, if you happen to have the schematics and are willing to share, please let me know, and it's much appreciated. So my plan here is actually to do at least a teardown of this unit. It is, after all, a generation newer than the 493A, and the circuits inside are all solid state instead of the vacuum tubes you saw in the 493A. Also, this unit has a much higher output power, roughly 20 watts over the range of 2 to 4 GHz, or in the S band. So it would be interesting to take a look. And I just removed some of the screws at the bottom, and so now I can slide the whole thing out. So I'm going to do that right now. So this should just go out like this. And it was relatively easy to remove the entire unit out from the outer metal case. And by the way, not sure if you can see these black stuff on the bench here. These are actually from the filter that is inserted between the guard and the fan. And the filter actually over the years disintegrated, and upon touching they turned into these kind of powder forms. In fact, this is quite common among these older equipment. You probably have seen this in some of my other teardowns, and whether or not it's the fan filter or it is the insulation foam inside, and over time they deteriorate, and upon touching they just fall right apart. Now, given the construction of this unit, as you can already probably see, later on I'm going to move the camera to a different angle so you can see better, but there are boards mounted on all sides, so it will be interesting to see how easy it is to at least take them out and take a closer look. So, which is what I'm going to do next. Let me rearrange the camera and we'll continue. Now you can see the top of this traveling wave tube amplifier, and I'm going to just flip it around so you can see the construction overall, what it's like. And as I mentioned, that it's going to be a little bit tricky to take off these boards, because the only way you can see the inside is to take the sideboards off, which going to be a little bit challenging here. As you can see that there are boards on every single side of this unit. So I'm going to leave this right now this way up, and gonna see if I can take some of the boards off. Now, without the schematics, it's going to be very difficult to figure out exactly what each section does. But from this layout here, you can see that these resistors are actually in series, and not sure if you can see the trace underneath, but they are indeed linked together. So this gives you an indication that this must be for the high voltage divider network or something like that. And given that there are some high voltage caps here, and so it's pretty reasonable to assume that this indeed is doing some high voltage stuff. Now, as you can see that there's also a high voltage transistor here, and there's some relays and a couple of relays here, and there's a 74, actually this is a 741, it's an op amp. If I can, yep, that's a 741 op amp. And one thing interesting to notice is that if you look at how the components are soldered onto the board, is that because back then I guess you don't have this through-hole plating type of technique for the PCBs, and so you can see that these are actually little standoffs on the backside of the PCB, and components are soldered onto that. So it's kind of like a double-sided approach, but it was more primitive than nowadays double-sided circuit board. And on this side of the board, you can see a bridge rectifier. Actually, there are a couple of these. And so not entirely sure what this does, but presumably some kind of a power supply type of a board. But there are not that many components populated on this board. And look at how neatly the wires are routed. And so these are actually common characteristics of the equipment built back in the days. But nevertheless, they are not that easy to service, because in order to service, you have to take these boards out, and how these are actually arranged is after the boards were in place, then we got these clipped together, and you can see that is fastened onto the board. So to remove these boards, to make it freely accessible, it's gonna take some. And before I started removing these boards, I'm just gonna kind of flip it over and take a look at what else we can see. So once we started removing these boards, it's gonna be very hard to, I guess, put them together, if not impossible. But you can probably see there's some power transistor devices in there, and those are probably for the regulator. And also here, there's some big capacitors, probably also for the power supply. And this is the reset button, by the way, here. Let me just move it over a little bit. That's the reset relay here. I'm not sure exactly how that is working here, because I cannot push this button, and it's supposed to be I suppose it's a momentary type of relay. I'm not even sure how this is working here, but that's something I have to do some investigation in order to get the thing back to working condition. And as you can see, that's the relay here. So this is currently just stuck in this position. I can't even press it. Not entirely sure how this is supposed to work, but if you know how this operates, please leave me a comment. That would be greatly appreciated. And in there we can also see this giant potentiometer that is for adjusting the helix current here, and also the fan back. Oh, oops, you can't see that. And the fan back there. So let me turn it around to see if we can spot anything else here. And now you can see that although I'm probably going to take this board out, but this underneath is the traveling wave tube. And because this is a 20-watt version, as you can see that this is clearly the output portion, because it has a heatsink here. And as the electron beam hits the target here, it generates a lot of heat. And for this high power output, we do need some kind of heat dissipation here. And all the wiring here, the coaxes are rigid coax. This is for the output, and this one here is for the input. So let's see, that's pretty much all the sides. So now I'm going to start taking the boards out, and so we can see things a little bit more clearly. Let me start with this board. Now with all these screws removed, I should be able to slide this out underneath this rigid coax. At least that was the plan. Yep, I can get it out. That is interesting. This board doesn't really have a lot of things on it, and I'm not really sure what these are. I have to cut open one of these heat shrink tubes to see, and by the look of it, it has 2 leads on each, so I assume these are just resistors, right? It could just be resistors, but there's no marking, so I have to take a closer look at that. No, of course, these are not resistors. These are actually high voltage capacitors. As you can see here, this is a 0.1 microfarad at 3 kilovolts, and the date code is 78. So this is a pretty old. I'm not sure if the capacitor is still good. These kind of capacitors usually last for a long time, not like the electrolytic capacitors. And so let's actually measure it in circuit to see if these capacitors are any good. And as you can see, that is indeed 100 nanofarad, so that shouldn't be a problem here. And with this board removed, we should be able to see the traveling wave tube in a little bit more clearly. And as you can see here, that black tube lying down there, that's our traveling wave tube. And I tried to Google to find this specific model. Unfortunately, I can't really find any information on this L-5561-02 tube. And if you have any information on this, please let me know. But the tube itself is also, as you can see, was made in year 78, the 44th week. So this is pretty old. Not sure if it is still in working condition. Okay, so I managed to remove this side of the board as well. This is what was sitting up here, and by the look of it, I'm not sure, this is a potted component. It looks like it's a big inductor, so I'm not sure if it's part of the high voltage circuitry or not. Maybe not. Maybe this is just an inductor for RC filtering, because we have a little bridge rectifier here, and as you can see, there's also a diode. And so I also removed this side a little bit. I can't take it out because as you can see that these are connected all over the place. But what I can see here is that we have a sort of a transformer here, and probably these are for the high voltage, I'm guessing, because this one right here, that's for the low voltage, as you can also see. And I can just move it a little bit here. And I don't want to totally disassemble this too much because I still wanted to be able to at least try to fix it. And without the board layout and all the schematics, it's going to be really difficult to do this kind of repair. So that's why I want to make sure that I don't totally disassemble this, and I won't be able to put it back. But anyway, so here is a LM309K, so that's your voltage regulator. So presumably that either is for, given it's how bulky it is, this is probably supplying the current for, the voltage for the filament here. But we have to trace it out. Anyway, so that's the regulator board. And if I flip this board over, you can see some other components underneath there, and these are the two big power transistors, I'm guessing, and probably part of that high voltage supply or low voltage supply, whatnot. And because of this traveling wave tube amplifier does not have any digital circuitry, so the entire analog portion is for the filament power supply and the high voltage power supply, and also for the high voltage time delay circuitry here. So now this board is actually the most interesting one, and it has a lot of components here. And the reason I haven't actually tried to power this unit up is because, number one, it probably had not been powered up for a long time, and number two is all these electrolytic capacitors look kind of have problematic, and I did measure a couple, and their readings are somewhat not reliable. So I need to kind of investigate a little more. And also the as we mentioned earlier, the reset switch, I'm not sure exactly what the problem with that relay is, and so I need to kind of take a look before going further. But we can see that here, this board is very interesting. We have this RCA CA3097E chip, and this one, after I did some research, it appears that this has a built-in silicon-controlled rectifier. And so not entirely sure what this chip is doing here, but presumably, and you can see that we also have this full bridge rectifier. And so it's doing some of voltage regulation, probably. I'm not entirely sure until we can trace the traces here and to see how the circuit is functioning. And here we also have a 54121. So this chip is actually a time delay, so it's a single shot generator here. And so presumably that is for generating the time delay for the high voltage. And the remaining stuff, we have a LM311D. This is a comparator here, and we have a bunch of transistors here. And so that's pretty much what we have on top of this chip, on top of this board. So that is pretty much what I wanted to cover in this video, and hopefully you find it interesting. I will also try to see if I can find more information and hopefully restore it to a working condition sometime in the future. In the meantime, if you have any information regarding this LogiMetrics 300 traveling wave amplifier, or even just the tube itself, please let me know. I will post high-resolution pictures of this teardown on my website, which is shown in the link below. Again, if you liked the video, please remember to give it a big thumbs up, and also remember to subscribe and share. I will catch up with you next time.